Download this code from codegive.com, link in the description below. Bad flags, the limits of simple design and a deep dive into feature toggles. Bad flags, often synonymous with feature flags or feature toggles used incorrectly, highlight the limitations of overly simplistic design and implementation in software development. While the core concept of feature flags, dynamically enabling or disabling features without redeployment, offers immense power and flexibility, a poor understanding of their implications and a lack of foresight can lead to a tangled mess of conditional logic, technical debt, and ultimately, increased complexity rather than simplification. This tutorial will delve into the concept of bad flags, explore common pitfalls, provide concrete code examples in Python, and discuss strategies for effectively managing feature flags to maximize their benefits while minimizing their risks. What are feature flags? At its heart, a feature flag is a Boolean variable that controls the visibility or behavior of a particular piece of functionality. It acts as a switch allowing you to release new features gradually instead of releasing a new feature to all users at once. You can enable it for a small percentage or a specific group, gathering feedback and making adjustments before a wider rollout. Perform A/B testing. Serve different versions of a feature to different users and track metrics to determine which version performs better. Disable problematic features. Quickly turn off a feature that's causing bugs or performance issues without requiring a full code deployment. Target specific user segments. Enable features only for users who meet certain criteria, example users on a specific subscription plan, users in a particular region. Decouple deployment from release. Deploy code with features disabled and then enable them later as needed. 2. The allure of simple flags, and why they can be deceptive. The simplicity of a basic feature flag implementation is undeniably appealing. It often starts with something like this in Python. This seems harmless enough. You have a Boolean flag, and your code branches based on its value. However, as your application grows and you add more features and more flags, this seemingly simple approach can quickly spiral out of control, leading to the dreaded bad flags. 3. Common pitfalls of bad flags. 1. Flag proliferation and technical debt. The biggest issue is that feature flags tend to accumulate. You add them for a specific release, and then forget to remove them after the feature is fully launched. This results in code clutter. Your code base becomes riddled with if/else statements based on flags that are no longer relevant. Reduced readability. The logic flow becomes harder to follow, making it more difficult to understand and maintain the code. Increased testing complexity. You have to test all possible combinations of flag values, which can exponentially increase the number of test cases. Flag fatigue. Developers become overwhelmed by the sheer number of flags and their impact on the system, making it difficult to reason about the code. Performance degradation. The constant evaluation of numerous flags, especially in performance-critical sections of the code, can add overhead. Example, proliferation. 2. Deeply nested conditional logic. Feature flags can lead to deeply nested if/else statements, especially when you have multiple flags that interact with each other. This can make the code extremely difficult to understand and maintain. Example, nested logic. 3. Leaky abstractions and code duplication. When flags are used extensively throughout the code base, they can leak abstractions and lead to code duplication. Instead of encapsulating the different behaviors behind a well-defined interface, the conditional logic is scattered everywhere. Example, code duplication. Notice how the logic for premium user pricing is duplicated across both the old and new pricing strategies. This violates the don't repeat yourself principle and makes it harder to change the pricing logic in the future. 4. Tight coupling to the feature flag system. Tying your code too closely to a specific feature flag library or system can make it difficult to switch to a different system in the future. You should strive to abstract away the flag system behind a well-defined interface. 5. Lack of visibility and control. Without a proper feature flag management system, it can be difficult to track which flags are currently active, who has access to change them, and what their impact on the system is. This lack of visibility can lead to confusion and errors. 4. Strategies for managing feature flags effectively, avoiding bad flags. 1. Treat feature flags as code. Feature flags are code, and they should be treated with the same level of care as any other part of your code base. This means code reviews have feature flag changes reviewed by other developers to ensure they are implemented correctly and don't introduce any regressions. Testing write unit tests and integration tests to verify that the feature flag logic is working as expected. Documentation document the purpose of each feature flag, its expected life cycle, and any dependencies it has. Version control store feature flag configurations in version control to track changes over time. To establish a feature flag lifecycle define a clear lifecycle for each feature flag, including creation when the flag is created and its purpose. Activation when the flag is enabled for different user segments. Deactivation when the flag is no longer needed and can be removed. This is crucial. Removal the process of removing the flag from the code base, and the associated dead code. This step is often skipped, leading to flag proliferation. Example, lifecycle implementation. 3. Categorize feature flags. Not all feature flags are created equal. Categorize them based on their purpose and expected duration. Release flags, or toggle flags used to gradually release new features to users. These are typically short-lived and should be removed once the feature is fully launched. Most prone to becoming bad flags. Experiment flags, or A/B testing flags used to run experiments and gather data. These are also short-lived and should be removed once the experiment is complete. Operational flags, or kill switches used to quickly disable features that are causing problems. These flags may be longer-lived, but should still be monitored and removed when no longer needed. Permission flags, or entitlement flags used to grant access to certain features based on user roles or permissions. These flags may be long-lived. 4. Use abstraction and dependency injection instead of scattering if/else statements throughout your code base, encapsulate the different behaviors behind a well-defined interface and use dependency injection to choose the correct implementation at runtime. This reduces code duplication, improves readability, and makes it easier to test the different behaviors. Example, abstraction and dependency injection. In this example, the discount strategy interface allows you to easily switch between different pricing strategies without modifying the pricing service class. This makes the code more flexible and easier to test. 5. Employ feature flag management platforms. Consider using a dedicated feature flag management platform such as LaunchDarkly, Split, or ConfigCat. These platforms provide features such as centralized flag management, a single place to create, manage, and track all your feature flags. Targeting and segmentation, the ability to target specific user segments with different flag values. Asterisk remote configuration. Asterisk the ability to change flag values without redeploying your code. Asterisk auditing and logging. Asterisk a record of all flag changes and their impact on the system. Asterisk integration with monitoring tools. Asterisk the ability to track the performance of features behind feature flags. 6. Automate flag removal. Asterisk implement automated processes to remove feature flags after they are no longer needed. This could involve asterisk scheduled tasks. Asterisk a script that periodically checks for flags that have been deactivated for a certain period of time and automatically removes them. Asterisk code analysis tools. Asterisk tools that can identify dead code related to feature flags and automatically remove it. Asterisk reminders. Asterisk set reminders in your issue tracker or calendar to review and remove feature flags after they have served their purpose. 7. Establish clear naming conventions. Asterisk use consistent and descriptive names for your feature flags. This makes it easier to understand the purpose of each flag and reduces the risk of confusion. Consider including the type of flag, example release, experiment, ops, in the name. For example, release_new_search_v1, experiment_promo_banner_variant_a, ops_disable_payment_processing. 8. Monitoring and alerting. Asterisk monitor the performance and stability of features behind feature flags. Set up alerts to notify you if a feature flag is causing problems. This will allow you to quickly disable the flag and mitigate the issue. V-code example, a more complex scenario and better approach. Let's imagine we're building a social media platform, and we want to roll out a new commenting system gradually. A naive approach might be. A better approach would involve an abstraction and perhaps targeting. Key improvements. Asterisk abstraction. Asterisk we define a comment service interface and concrete implementations for the old and new systems. Asterisk dependency injection. Asterisk the post_comment function receives a comment service instance, allowing us to switch between implementations easily. Asterisk targeting. Asterisk instead of a global boolean, we can target specific user groups, early_adopters. This opens the door to much more sophisticated rollout strategies. The get_comment_service function acts as a factory, resolving which service to use based on user characteristics. This second approach is more flexible, testable, and maintainable. It avoids the pitfalls of scattered conditional logic and tight coupling. 6. Conclusion: feature flags done right. Feature flags are a powerful tool for managing software releases and experiments, but they require careful planning and execution. By understanding the pitfalls of bad flags and adopting the strategies outlined in this tutorial, you can leverage feature flags to improve the agility, reliability, and maintainability of your applications. Remember to plan your flags, define their purpose, scope, and life cycle. Categorize your flags, understand their different types and how they should be managed. Use abstraction and dependency injection. Avoid scattering conditional logic throughout your code base. Employ feature flag management platforms. Take advantage of the tools and features they offer. Automate flag removal. Prevent flag proliferation and technical debt. Monitor your flags. Track their performance and impact on the system. By following these guidelines, you can harness the power of feature flags while avoiding the trap of bad flags. Happy toggling! Remember that regular review and cleanup of your feature flag implementation are critical for long-term maintainability. Don't let your feature flags turn into a tangled web of technical debt.